Alright, so in this problem, I have x to the power of 3 plus x is equal to 10. So to solve this, I'm going to first start by subtracting 10 on both sides. So if I subtract 10 on both sides, these two cancel out, and I get x to the power of 3 plus x minus 10 is equal to 0. Now, from here, to actually find all of the solutions for this equation, we have to first start by finding one solution and then use that one solution to find the rest. So how are we going to find that one solution? Well, we're going to simply have to guess. So let's start with x equals 1. When x equals 1, I get 1 to the power of 3 plus 1 minus 10, and this is equal to negative 8, which does not equal 0, which is wrong. Now let's try x equals 2. When x equals 2, I get 2 to the power of 3 plus 2 minus 10. 2 to the power of 3 is 8, 8 plus 2 is 10, 10 minus 10 is 0, so this works. So now that we have one solution of x, we can use this solution to find out the rest of the solutions. And how are we going to do that? Well, if x equals 2, this means that x minus 2 is a factor of our original equation, because if we plug in 2 for x minus 2, that equals 0. This means that I have to divide x minus 2 with x squared plus x minus 10. However, this also means what we can do is we can rewrite x to the power of 3 plus x minus 10 as, well, what's 2 squared? 2 squared is 4, so I get plus 4x, and then because we have plus 4x, what is x? What is 4x plus what is equal to x? Well, 4x minus 3x, or we could also do 5x minus 4x. So we get 5x minus 4x minus 10 is equal to 0. Now, what I'm going to do is I'm going to factor by grouping. So we can group x to the power of 3 plus 5x and negative 4x minus 10. Well, x to the power of 3 plus 5x, the greatest common factor is x. However, this won't work because x squared plus 5, that can't be simplified. So what I'm going to do is rewrite this as x to the power of 3 minus 4x plus 5x minus 10 is equal to 0. So now, if I factor by grouping, the greatest common factor from x to the power of 3 minus 4x is x, so I get x times x squared minus 4, plus from 5x minus 10, the greatest common factor is 5. So I get 5 times x minus 2 is equal to 0. Now x squared minus 4, I can rewrite that as x plus 2 times x minus 2. And I have this plus 5 times x minus 2 is equal to 0. Now from here, I can factor out x minus 2, so I get x minus 2 times x plus 2 plus 5 is equal to 0. And this simplifies to x minus 2 times x squared plus 2x plus 5 is equal to 0. Now this gives me two equations. I get x minus 2 is equal to 0, and I get x squared plus 2x plus 5 is equal to 0. Well, for x minus 2 equals 0, I can simply add 2 on both sides, so I get x equals 2. And we already got the solution by guessing at the start. Now for x squared plus 2x plus 5 equals 0, I can use the quadratic formula. So in this case, I get negative 2 plus or minus the square root of b squared, which is 4, minus 4 times a times c all over 2a. And this is equal to negative 2 plus or minus the square root of 4 minus 20, which is negative 16 over 2. And you can't take the square root of negative numbers, so there's no solution for this, meaning my only solution to this equation is x equals 2.
Alright, so in this video, I'm going to be solving the equation 5 to the power of x is equal to 50. So to first start with this problem, let's test different values of x. So if x is 1, then I get 5 to the power of 1, which is equal to 5, and this is too low. Now if x equals 2, I get 5 to the power of 2, which is 25, and this again is too low. Now if x equals 3, then I have 5 to the power of 3, which is 125, and this is way too high. So we know that the value of x is going to be somewhere in between 2 and 3, meaning it's going to be a decimal. So how are we going to find the exact value of x? Well, to start, we're going to be using logarithms. So I'm going to take the log on both sides, so I get log 5 to the power of x is equal to log 50. And the reason I'm doing this is because logarithms come with a special property that state that if I have something in the form log a to the power of b, I can actually move the exponent b to the front, so this turns into b times log a. So in this case, I have log 5 to the power of x, and we can think of x as b, and I can move this x to the front, so now I get x times log 5 is equal to log 50. And now remember, we want to find the value of x, so all we have to do that is to get rid of this log 5 by dividing both sides by log 5. So now these two cancel out, and I get x is equal to log 50 over log 5. And now let's simplify this a little to get the exact decimal value. So log 50 is the same thing as log of 10 times 5. And another property of logarithms is that if I have something in the form log of a times b, this is equal to log a plus log b. So now this turns into log 10 plus log 5 over log 5, which is the same thing as log 10 over log 5 plus log 5 over log 5, which is just 1. And log 10 is also equal to 1. So I get x equals 1 over log 5 plus 1. So now all that's left to do is do 1 divided by log 5 in my calculator. So I get x is equal to 1.431 plus 1, which is equal to 2.431. So this is my answer.